Again. Oh shit. I think it's not used to streaming, so there we are. Just have to resend the link again, so just a second. Fuck. Um, just a second. Alright, just a second. Sorry about this. I'm just gonna have to cut out. Can't believe it just cut out like that. Just a second. Okay. Just a second. Yep. Alright. So. Yeah, okay, that's fine. So here we are. So what this is talking about object equality here, and they're basically what this does is we go back to what this basically does is it takes it's absolute object equality. So the objects have to be totally equal. It's not just a return type. It has to check everything. So in the case of like JavaScript, they have this they do the same thing with triple equals. So that sort of shit, basically. Anyway, yeah, they do that. So what methods are required? So that's object equality. What methods are required? It's documented in the design. Public array list. Watch method requires a little more explanation. It should have the following signature. Okay, so what this does is this is canonical form because you have well, this is different actually, we'll go through this later, but int a private fields which is about data hiding, because in canonical form you have to have at least three things. You need to have data hiding, data accessibility, which is done by these get methods, bloody Discord, sorry, and then you have these, and then you have a toString method as well, which should be, yeah, there we are. And then a static int next time, which static incrementing, yeah, private static int. So the method does not change with the static method, which is basically what it is. So going next from that, public array list student 1 search key, all the students in the directory, student 1 test, is it test school directory? I don't think it might be. No, this is tests. This is later. School directory. Public array list student. Search by key, string key. Here we are. Student. Search by key. Yeah, so what this does is, it's basically an array list method, because this is what it returns. And also in Java methods generally, you have two types. You have one that returns a value, or a void method which returns nothing, because it either iterates or prints something out on the screen like system out print line. So we've got that array list student, which takes in the student as its value, and then you've got search by key, string key. Well, this is a parameter, so this is a thing that you take in. So what this does is it creates a new array list for students. So this is an enhanced for loop, which I haven't really done, but it's sort of like a more compacted for loop that adds stuff. It does more, because you have to, with a normal for loop, you have to add stuff in there, like a array list get I normally. If key equals integer dot toString, s get hun equals s get name. Well, this is an or statement here, so this is actually, yeah. And then results to add I. So results Yeah, and then you just add using that if it's an if statement, and then you return all these results here because you create a new array list in this method and you have to return it. So that's why you've got an array list of student objects here. Download the lab codezip file. Yeah, okay. JUnit to the build path. JUnit testing, okay. This is a JUnit test. We're going to the test now. So, yeah. No implementation can be complete until it has been tested. You created some unit tests in the Java. Yeah, BlueJ. Yeah, this is JUnit testing. Okay, this is just run as JUnit test. Okay, let's have a look. Test student 1. So let's have a look at JUnit because you need to have before and after. Well, tear down is after, but before you need to set up the whole thing. You need to reset before each test. So this, what it does, it resets everything because of the new test, and it adds students every time. And then test assert equals. What this basically means is it has to equal 1 and 2, and you use the get methods for this to get it. And then that's another test. Test set name assert equals. This is the name, and if you use student.getName, this is what you get here. So then test fails. I'm not going to do this, but test following the name method testing. Test fails if import to test pupils method. I think they have another test here. Test equals school directory. Assert equals school directory equals. Yeah. So this is a bunch of assert equals basically. Assert not equal is the opposite, so it returns false. Well, the test passes if they're not equal. Test pupils. Here we are. Here it goes. Bloody Discord. Sorry. Public void test pupils. School directory is new school directory. Assert false. sd.toString contains Harry. Yeah. So that basically does the method on what you created earlier. What you created here. So you just assert sd remove pupil Harry. Here we are. So this is all the different methods you can have because assert. What you need to have is you need to do the return type on the right hand side, what it's going to be equal to, or false, whatever, and then you need to have the method on the the left hand side is what you return, and the method is on the right hand side. So that's how asserts work. And they have assert like equals object where you just compare objects. That's different. Object, for example, if it's hash set, try using link hash set instead. Compare the two. Running Java. Oh, this is optional. So, and this is just Java docs and stuff. So this is different. So we've completed the first one. Let's just close this. Close project. Here we are. We've got on to number 2 now. And alright. So this is investigate the use of inheritance from program structure. At the end of the lab class, you'll be able to explain how subclasses interact with their superclass. Operation and planning. Rest of the lab sheet. Section 3, what is your goal? Gather information. Dome. So we start with Dome. Okay. And here's what Java packages. Another thing, which it might be an exam, is you might have to create some new packages. Basically, what packages do, they group the different classes that are relevant together. And you import packages in, say if you're using a different class, you import packages basically. So yeah, there we are. And okay, boardgame.java, here we are. Dome v2, yeah, using Eclipse you can view the class hierarchy as follows. Right click on the project, that's fine. Create a CG object and see its methods. And this is Scrapbook, so we won't be tested on this, but this is it is a scrapbook exactly, like you can test stuff with it. And this is just testing. Hierarchy, which of the assignments are legal and why? To run some tests, the following lines of Java can be found in test assigned.txt. You should either write a test class or import them in Scrapbook. Well, this is the thing. You have to do this new object and cd2 and okay. Compiler errors. cast statements. Yeah, casting. Casting is another thing, where basically what that means is you can change the type of an object, which is also called polymorphism as well. Oh, bloody hell, sorry, Discord. To mute Discord. Sorry. I'm gonna have to mute it for the fucking time being. Yeah, sorry about that. Anyway, what here it is. Here's what this is. This is a UML diagram, which basically means these things are all a subclass of this. So they inherit this class, and these use these to create these basically. And a subclass, what we do here is what these do is we're gonna do abstract classes come later, but what you do here is with subclasses and superclasses, in a basic way, you can have this and you can have this. Like, you can have this or you can have a whole of this, but you can't have just this. So it's a bit weird, I know, but and this is further subclasses. Create some video game, Hogwarts. Alright, this is we're gonna go through this now. Boardgame.java, cd.java, extends item, boardgame. Yeah, exactly, so this just adds stuff to it, and you have to have a supercall in this for all the relevant fields in a board game, in a game class. Number of players, and you need to have a title, playing time, got it, comment. So yeah, and you need to have that sort of thing there. You always need to have a supercall in something. So let's have a look at CD class now, which has artist, number of tracks. So you see that in the UML diagram. That's a minus sign like that basically means it's private. So here we are, private in number of tracks, and then you have a supercall. This title, time. So yeah, that's basically what all of these are. Is they're subclasses of that. So. And you need that, so title, playing time, got it, comment, title, playing time, yeah, there we are, comment string, there we are, and what this does is, super class, this is title and time that you need to put in, and this is just with parameters, you assign it to the private variables there, so print, that's just a print method, get artist and artist. Have a look at this database. Well, this is it. We're going to array list items now. So this is where polymorphism comes in, because this item is a superclass of these subclasses. So you can have just an item, or you can have these types of items, since they extend what item does. And this just creates a new array list. This is basically basic, where it just prints out the lists and creates it and stuff. So demo database, for example. And you see this is how we do it. We need to create this stuff, and then you just add it to the database. There, in game, go to game now. Oops. There we are. Int number of players, game string, the title, int time, int n players, super, the title time. So exactly, that's, you have the basic fields there. For there, I'll just have a look actually. Item. Yeah, so that's just comment. There we go. So what this does is it just has the methods that you see there. With game, for example, number of players, it just stores there. The set number of players is where you set it, and get number of players is where you get it as well. And that's basically it. It's just superclass and subclass. So now we're going to move on to Hogwarts task now. Lab 2 Hogwarts. There we go. Hogwarts system enables you to store information about lower school students. Download the Hogwarts the upper student class, or the existing class, for the student can be reused. Student to derive upper student for student 1. Draw a diagram of the relationship. You have a constructor with the L grade is set and an access method get grade. Okay, we'll have a look at this. Student 1 string name, next time return name, boolean equals object. So that was exactly what we did in the first task. But upper student, you see here, extend student, al grade, upper student, string name int year, char, and then super name year, student 1, where it simply extends that. And this is a quick way basically to create parameters and variables that are the same name. It's just a quick way to do it, and you see you need the super call to get the methods there basically. Yeah. This needs to be tested. We'll have a look at the tests because we need to write test 2 in the exam. So boolean test equality. So this is a static method, which means it doesn't change either. And for int d1 enroll for static boolean test score directory. So this is an example directory. It's not actually a proper test class, but there we are. ToString that tells directory numbers of people. Not so surprising to find a ToString method, because this, like I said, a ToString is a thing, part of a canonical form as well. So super ToString. Well, this is the thing with methods. You can write in a superclass and a subclass. You can write ToString methods that are different, but with to invoke the super method over the sub method, you use the super call to do that, and that's basically what you do, casting down the hierarchy. But you can only cast up. You see, you can only make a superclass is equal to a subclass. A subclass cannot be equal to a superclass, and I think that does it for this. Just going through it quickly. So close project. Here we are. Go on to task 3. So this is dynamic types of method overriding, dynamic static types, dynamic binding, protected number. Okay, preparation and planning, dome. Okay, first of all, lab 3. You went through the sheet twice. Send the dome specification, dome v2. Dome project, add a print method to the class item. Again, write the method body. Demo database. Yeah, that's fine. ToString methods. So that's basically using what we did last time. So Zool. We're gonna go to Zool now. It was discovered in lecture 3. Download the Zool 2. The transporter room with inheritance of the Zool game. Okay. Have a look at this. Yeah, transporter room extends room. Here we are, and a room set exactly. This is a set of rooms. So transporter room string description, super description, because you're setting up. It's a subclass of the room, so you need to put a description in the room class. And then these are just going back to canonical form. You need getters and setters as well. So okay. Anyway, so the task is to implement a transporter room with inheritance to the Zool game. A transporter room represents a location in the making room as an abstract class, as a subclass of room, as a subclass of room. So basically, what abstract class is, the difference between a subclass or a standard sub and superclass hierarchy and a abstract class hierarchy is that an abstract class cannot be created unless you have a subclass. So it's closely coupled to the subclass. So with the previous, with the item and with the items and stuff like that. What's the room class? Can I see it? Okay. Yeah, I'm going to go on to that. What I was going to say was, do the well, what I was going to say was the abstract class is basically a tightly coupled version of a subclass and superclass relationship, because in a standard subclass and superclass relationship, you can create a superclass without a subclass, whereas in an abstract class, you need a subclass to create an abstract class, because if you try and create a superclass in an abstract, a superclass, which is an abstract class, it would fail. So we'll go back to the room. Okay, so public abstract class room, private string description, protected hash map string, edit, exits. Which protected methods, this is interesting because with protected methods you don't need an accessor method inside the subclass to get it, because you do class dot whatever the variable is called to get it. You don't. That's why you use protected in here. We're an abstract class. You need to modify the room class to make it abstract and fields accessible to subclasses only. Make the method get exit abstract as well. We're gonna have a look at this. So description, public room description. So this is when you set it up, and exits is a new hash map which you set up in the protected here, because you're gonna use that in the subclass, so you need to create it in the super. Set exit. So this is just a normal exit method, and we're going to have a look at the abstract. This is just normal accessor methods, part of canonical form. Abstract room, here we are. So the thing with abstract methods is they're method stubs, whereas in a subclass you just put public room get exit. So in a subclass, let's say room set, I think. Not room set. It's transport room. You need to extend it, and then you need to get the room get exit. Let's have a look here. You need to modify the room class to make it abstract, make the fields accessible. Definition of get exit should be moved to a new concrete class, normal room, that extends room. Oh, here it is, normal room. I was looking for that. Here we are. Public room get exit string direction return room exit get direction. What this does is, like I was saying with the abstract class, you just put a method stub inside the abstract class, whereas in this one you have to put the what do you call it, the actual implementation of it. And we're going to go into interfaces later, which is even more tightly coupled than an abstract class, because you can't even have constructors in that. You just have implementations, not implementations, like specifications of things. Definition, should we get exit? Find random room, which is used in transport room. We'll have a look at that now. Find random room, return rooms. Yeah, so we need to use that. That's in random number generator, I think. Find random room. Is it somewhere here? Can't see it. Have a look. Room. Oh, it probably been room set actually. There we are. Find random room. Here we are. If room is empty, return null. Else int random position equals generate dot next int rooms dot size return rooms dot get are in position. Basically, what this does is how random number generators work. You give it a limit for it to generate by. So it generates a number by 1 up to a limit that you've set. So in this case, it's the size of the array list. So if this happens, then the number that's returned cannot be greater than the maximum number of rooms in the array list. So what this does is it basically cannot produce an array, cannot produce too high a number. And what this does is it feeds back into the array list, because an array list you have a get method to return an object corresponding to a certain integer within that array list, and you use that random number to get it. So I think that's done. Use line can be described as follows. Class diagrams. Let's have a look at class diagram. What this does is, it's basically, this was the sort of like the cardinality in a UML diagram. It basically means you can have one or more of these, and this is a subclass of room, and that's a subclass of room as well. And basically what that does is, this is a delegation pattern. This is the delegation because they're linked. So these methods are linked, but you can have one or more of these. You need to have one or more of these, and these are all. This is UML, which is actually part of the exam too. And the test. Let's have a look. Where are the tests? Public void your test room set equals new room set new random 42. other code. So this is a test in an instance which you create a new room set and you have to create a new random which is 42, which basically sets the maximum number of rooms you have in that set. Transport room class in for the game create room to create a room set. So I think that's most of it done. Third task at least. So that's sorted. Going to task 4. Close this. That's project. Lab 4 code. Let's have a look. Where now? This is systems using abstract classes as an interface. Yeah, now it gets important actually. Now we need to start basically paying attention. And this was the foxes and rabbits task that they might ask in the exam actually. They might ask about this. Use abstract classes interface, flexible and efficient designs, assessment. You do enough preparations, command line arguments, and the main routine which can then process them. Argument and Eclipse run over dialog menu. This is a simulated class and find the main method. Let's go now. Let's just make this smaller. Make this smaller to extend to the center. There we are. Okay. Simulated class, the main method. The main string argument. So what this does is, I think it's on different languages you have C# and like other things, they have this default method which basically puts in arguments as an array and you can basically return it, and when you see in different IDEs they usually have return 0 because that method is where most things are put. So int num steps equals 1 by default, args.length is greater than or equal to 1, num steps integer pass int args 0. Yeah, so it actually passes in through an array which uses that int seed equals 42. So what a constructed what this does, it basically sets stuff up. What args is an array of strings containing command line arguments. As a purely hypothetical example, if you run a program test C putting 42 and hello on separate lines of the argument dialog box from the command line with Java test, and args 0 contains a string 42. Okay. You may have to convert the string into a variable of different type. We need an int value. Unless it belongs to integer wrapper class. Well, wrapper class is different because you have like it's different to like a variable because wrapper classes, they have set methods that you can do on them. So like a parse int or a string or a something like that. Well, the usual way you'll find differences between wrapper classes and normal variables is if you have the uppercase and lowercase, and they might be spelt differently too. That's the main way you'd tell. So useful, convert string to variable, and the lines of 12 work correctly. These are lines 9 to 12, have a look. That's weird. That is weird. No idea. Sorry, because they edits that. Random number generators generates numbers in a certain range with equal probability. Should be covered in the module. Yes, maths with computing professionals. What this is basically doing is it takes in a certain modulus number, and what it divides by that number and returns. It uses that to return the remainder. Basically, that's how random gens work. So yeah. Computer programs usually not random at all, as they are deterministic algorithm. Exactly. So same statistical probability, random number generator, the seed of 42. Import Java util. What this import statement does is it imports every package into here. So you use the import Java util random is what you normally use if you just want the random class. Random gen equals new random 42, which 42 is basically the limit for the numbers, and double x equals gen dot get next double, which basically what that does is it returns a double up to and including 42.0. And difference between a double and a normal number is that a double can have decimals in, whereas an integer or an int has to have a singular value, so it has to be a whole number. It would return an error if you say did say return 11.0 or something. Yeah, okay. The next int n method returns an int chosen from the range 0 to n minus 1 with equal probability. Simulate the. Well, actually, he makes a good point here, because as was shown previously in the array list, when you put a random number in, the length of an array list is basically the length of the first item, including, because an array list starts from, well, for anything, an array list, a hash map, whatever, it starts from 0. So, and that's the way to return it. It's 0 up to n minus 1 values, because it counts 0 as the first starting value. So that's why you use that, because it has to return something less than 1. How the run generator works. Run the test run program. Let's have a look. Test run. Okay. See the run generator. Edit test run. Simulation programs. We need to get to the abstraction. Here we are. Now it gets to the meat and potatoes of this whole thing. Start work. It's no good trying it. Okay. Using Eclipse, you see warning signs. Yellow triangle for the class Fox. Well, I don't get anything because this is a solution code, so I'm gonna have a look. Move the age, alive, and location attributes to the animal class. Let's have a look. Oh, and this actor interface: private, protected, boolean, alive, protected, location. Yeah, construct a live animal with age is equal to 0, alive is equal to true. Like we said before, protected means it can be accessed in the subclass using a dot. So let's say method dot variable rather than, no, sorry, a class dot variable, because normally you do class dot get something for a get method in a canonical form, whereas here you just return the variable itself. So now to construct provide accessor mutator methods for the age field, because like they said, it's private, and what is necessary if you construct make the fields protected in animals. So what it considers to be necessary, whereas accessor methods for these is not needed, because we just use the class itself to do that. Create an abstract act method with the following signature. Here we are. So public abstract act. So these take things as parameters in. So in an abstract class, you have to put public abstract, and then with a return type, obviously, and with the parameters in, because abstract and interface methods are just stubs. So you need to provide the implementation of these methods or whatever in the actual subclasses themselves. So rename the setEater method of rabbit to setDead and move the method to the animal class. Let's have a look. SetEaten, setDead. Alive equals false. So that just basically changes it to alive. And move the method to the animal class. Make other changes to fox and rabbit classes. Let's have a look at the fox and rabbit classes quickly. Extends animal, because these are all things you need to public static final, and you set these things in the variables themselves, so you can't set these things in as parameters or input values. You need to set them final. Private static final, so these are encapsulated inside this method basically, and you can't change these. So public fox boolean random gen super, well, it doesn't have any super constructor actually. Age, set age. Well, the thing is, it doesn't have a constructor because you set the age using this here, food level, void act, and you see this act because you have the same signature as the abstract method, but you don't have. But you have to put the method here. So increment age, use the methods outlined previously to do that. So setEat and setDead, make sure the changes. Using Eclipse, you might find it useful. Modify the client code and simulated field classes to use the animal class. Let's have a look. Yeah, so you've got all these things here. static void, new actor, run long sim, emulate, new actors, clear, void, reset. It's got all these things here. Simulator to use animal class. Populate. If and Nox fox, unique fox, true. And that basically sets the fox to true. Animals to add, that just adds it to the list. Fox.set location, row call. So these are just parameters. You need to use these to set the fox. And these are all just static values here. Populate, the concrete type must be used. However, the code effectively identical. Assigning the created object to a variable animal type means these guidelines will be removed carefully outside the if statements. Yeah, okay. Simulate on step, using animal instead. Similarly, if field. Cambridge methods, determine it identical. We did not need to move this is because the access class variables for in subclasses. Yeah, are these changes sufficient to tweak of other? What is missing from can breed? Let's have a look at the animal class again. Can breed. So here we are. Return age is greater than or equal to breeding age. Okay. Increment age, fox rabbits to animal, finding an abstract. Get max age method in animal and a concrete version in fox and rabbit. Okay. Get max age. Yeah, because get where is it? Animal class. At oh, here we are. Get max age, and you get breeding age. Get max age, like I said earlier. You have they're just abstract methods. So you need to put the concrete implementation in the subclasses. Same with interfaces even. Hierarchy. The type hierarchy. Right click the project in the package explorer. Let's have a look. And set the appropriate menu item. Oh, okay. This is interesting. Assign working sets. Yeah, I'll have a look later. What is it? Facilitate changes, impact. Optional. Let's have a look at optional. Superclass. List type. Appropriate changes. Iteration of simulator. Define a completely new type of animal with a subclass of animal. You need to decide what type of impact. Following actor interface. Here we are. I'll have a look at this now. This is getting back. It's getting interesting. Oh, here we are. Public abstract void. Well, actually, in interfaces, you don't need to provide the public abstract because they're already set for you. So actually, in interfaces, you just need to put void, boolean, void for each method, respectively, because it's a given in interfaces. And I think you need to. I think you can only have static field interfaces too. Actually, static final. I think. Quick look, correct simulator step method in simulator to use actor instead of animal. Simulator to use actor instead of animal. Okay. Simulate one step. New actor dot clear. Okay. So this is, yeah, you've just got the interface here. Actor instead of animal, you can do this even if you've not introduced any new participant types. Title to the actors and new actors respectively. Challenge exercise, add a non-animal actor to the simulation. For example, you could use this. Experimenting with the simulation, here we are. And this is just running the simulation. Let's see if I can do it even. Run. Run. Can I run it? Oh, cool. Oh, it works. That's interesting. Ah. So it does work. That's interesting. So, yeah, that is quite interesting. So that does work, but it's static. So step one, can you? I'm not sure if you can iterate through that at all. That's weird. But anyway, I think that's it for lab 4. So now we go to 5. Let's close projects. No, oh, whoops. Oh, here we are. We do close project. Here we are. Lab 5 and lab 7. Well, while there isn't lab 6, it's because it's a GUI lab, and we won't have any GUI stuff in the exam tomorrow. So you can consolidate your abstract classes of. Should be able to refactor an application using Java interface so you can generate multiple of single model, structure view of classes, HTML documentation using Java comment, unit testing of view, JUnit testing. Assert statement, that to the current value. The test, let it void 2 increment, C1 increment, assert equals 1. Let's see, where's this, here we are. Test was the test for the name of the method. Yeah, test tag tells create this method as a test created in setup. What is this? It's available in initial state. Okay. Well, setup and tear down. Setup is basically where you set all this up and you test it, and tear down is what you do after this test, where you might reset or something. Create a test class for location. Let's have a look. Don't think the tests are here, but have a look. So that's just a setup method where you set it and then you test it. Cert equals loc1 loc3. So that basically tests if these things are equal, because usually in a cert equals method you put the return type and then you put the method on this side, but for this one you just put them to equals, and then assert false is basically if this equals that, then it passes if these two are false. Subsystems and packages. At the moment the foxes and rabbits simulation puts all the oh, where's my mouse going mad? That's weird. This does not make clear the distinction between different groups of classes. In the section you'll put that right. Download and open the Lab 5 code, packages in the form, module. Yeah, here we are. That's it. That's just packages. Rather after this is just moving around packages. So you need to import the model package. Yep. New views. You can imagine other different ways to do the simulation. Display could show the field a new iconic image for the app to keep things simple at the stage which is implement last DGs. With the current design, creating a new type of view not only requires work to complete the new view, but it also entails many changes to the simulator class. We should use an interface to decouple the two aspects more completely. Our aim is to put an interface above the simulator view class, so it currently uses to manage display. We should call the interface simulator view because it's a good generic name. Described in chapter 10 of the Blue book. If you analyze the unit of the application, you'll find that the methods are. And this is JavaDoc actually, pointing this out. When you use the JavaDoc application to create this, it put this automatically into some HTML documentation. Other relevant method signatures. Simulator view class. Let's have a look. Animated view. Let's have a look. Set title, step label, color, colors that get color. Let's try and run this, see what happens. Run. It'll be launched and there's no recent launches. Probably won't compile. Implement simulator view, animated view set color method, simulator view interface. Oh, here we are. Yeah. Like I was saying earlier, you don't need to put public abstract void in an interface. You just put void. Next, of course, set color by appropriate course register class. You'll find then the main constructor. All the reference simulator views should say they are except to one when the view structure is animated view. Let's go to this now. Let's go to line by line. So these are all just final, where you just set the colors before it starts, and well, a bunch of things actually. And private obviously is it's private, so it's put in without that class. You can't access it without a get method. Exit app, system exit equals 0, class extends actor, annotated view colors, set text, field reset, show status, field view extends. Oh, okay, yeah. So you can actually, this is a abstract class that you use. And you have, yeah, and public void, here we are. Are you ready to add test view of the simulation? Test view or text view? Might be text view. Ah, here we are, yep. Implements simulator view, public text view, and nothing to create, public void register class extends actor, and void show status instep. Step for step, field got get